Let's look at the difference between ionic versus covalent bonds. So if we were to differentiate the two, we can say that an ionic bond is a bond between a metal and a nonmetal, whereas a covalent bond is between two nonmetals. So if you see a metal, you know it's ionic. If you don't see a metal, it's going to be covalent. We can also say that if there is a large electronegativity difference, it's going to be ionic. And if there's a small electronegativity difference, which can be said to be between 0 to about 1.7 difference in electronegativity, it's going to be covalent. One more thing to note is that an ionic is a complete transfer of electrons going completely from one to the other, whereas for covalent, it is a sharing of electron. For ionic, we want to get to a stable position by either having no valence electrons or having 8. So there's going to be a complete transfer so that part of the molecule can get to 0, the other part can get to 8. Whereas covalent, they're both depending on each other. They're both using each other's electrons. Now for covalent, it can either be polar or non-polar. The sharing of these electrons could be equal, there could be an equal pull, or it could be unequal. But regardless, the fact that both of the atoms that are involved in the bond are sharing them and not transferring from one to the other would mean that it's covalent. So let's look at our first example of NaCl, sodium chloride or table salt. Would this be ionic or covalent? Well, here we have sodium and chlorine. Sodium is a metal. It is our Na plus with our Cl minus. We have a nonmetal in the chlorine and a metal in the sodium, making this ionic. Well, what about H2O? Let's look at the two atoms that are involved, hydrogen and oxygen. Both of them are non-metals. So we're going to say this is covalent. Now, let's look at another one relatively similar. CO2. Do we have any metals present? We do not. Carbon and oxygen are both non-metals. So, this is going to be covalent. What about, on the top, magnesium chloride, MgCl? Well, magnesium is a metal, and chlorine is a non-metal. So this is going to be ionic. So for our two ionics, they're both group 1 metals, meaning that they have one valence electron. They want to be in a stable position. They want 0 electrons. Chlorine is group 7, so it needs one more electron to get to a stable octet, to get to 8 valence electrons. So both of them are going to be stable by either completely gaining or completely losing an electron. So that's how we also know that this is going to be ionic, because the magnesium, or in our first example, the sodium, want to completely get rid of that electron so that they're more stable. And for both of them, the chlorine, which is at 7 valence electrons, wants that one more so it gets to that full octet. So what if we have NH4Cl? Well, what is NH4Cl made of? It's made out of a polyatomic ion in NH4 and in chlorine, in Cl. There's a couple ways we can approach this. First, we can say that NH4 has a plus charge when it's by itself, and Cl has a minus. Both of these are ions. We're dealing with two ions, just like in an ionic compound, like NaCl. We have a plus charge and a minus charge. They come together with an ionic bond, and they become overall neutral. That's exactly what we have here. So this is one way we can determine that this is going to be an ionic bond. But are there any covalent bonds in here? Well, within our polyatomic ion, we have nitrogen bonded to hydrogen. There's still bonds going on here. So even though the polyatomic ion and the chlorine ion are bonded to each other with an ionic bond, within the polyatomic ion, there are covalent bonds because the nitrogen, a nonmetal, is bonded to hydrogen, another nonmetal. So internally, our NH4 is going to be covalent. And then if we're looking at it as an ion as a whole, it's going to have an ionic bond with our chlorine. So this is going to have covalent bonds within and ionic bonds with the chlorine.